It's time for equivalent fractions. See, it's like equal sign. That means like they're the same, like equal, equivalent. Like the fractions will be the same. Oh, okay. Well, firstly here, let's look at this problem. We have 3/4 is equal to 9 over some number we don't know. But we will know what that number is. Now, we need to figure out how can I change this 3 into the 9. Okay. So, yeah, we could like add 6 here. And that would be 9. But we need to make sure that we are only multiplying like that kind of thing, or we are dividing. Now, what am I going to do here? Since the 3 is becoming a 9, it's getting greater, we are going to have to either, like I said, multiply or divide. Which one would we do if the number's getting greater? Well, we would multiply. So we have to think. 3 multiplied by what number is 9? 3. And then what you do to the top, you do to the bottom. And then what you do to the bottom, you do to the top. So, since I multiply the top by 3, multiply the bottom by 3. Now, 3 multiplied by 3 is 9. And then 4 multiplied by 3 is 12. So then I know my equivalent fraction is 9 over 12. And 3 over 4. So they are the same, but they don't really look the same. Like, these numbers are different. How in the world are these things supposed to be equal whenever they look so different? Well, with numbers, they may look different, but let us look at it as though it's like this picture here. So, for the first one here, we have 9 over 12 now. So we have 12 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Equal, kind of. They should be equal. And then up here, how many different sections should there be? How many different, like, rectangular shapes should there be up here? 4. The bottom is the total number, so 1, 2, 3, 4. Now, if we look at it, we are going to color in 3 of the 4 boxes. 4 boxes, 1, 2, 3, 4. Color in 3 of them. 1, 2, 3. Now, this is equal to 3 over 4, 3/4. Now we have the bottom one here. How many am I going to fill in for this shape? I'm going to fill in 9. 9 of the 12. There are 12. I'm going to color in 9 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, Mr. Ely didn't do a perfect job drawing these things, but if Mr. Ely did do a perfect job, which would be perfect, these would be equal. They are the same. They should be the same. So even though the numbers are different, equivalent fractions mean that both of these fractions are the same. So let's take a look at another option. Another problem here. Trying to make them equivalent. Remember, the numbers are getting bigger, so I can only multiply or divide, but since they're getting bigger, I'm going to multiply. 8 multiplied by what number is 24? 4. Then what do? What you do to the bottom, you do to the top. So, I'm going to rewrite it. 3 over 8, which is correct, equals 24, and then I do the top up here to get this answer, and that answer is 12. Equivalent fractions. Last one. So if we look here, we need to make sure to make them equivalent. But if we look in this case, yeah, if we go this direction, the number is getting bigger, but if we go this way, it's getting smaller. So I'm going to need to be dividing by something. So the way to figure out what number I'm going to divide by is by dividing these two numbers here. You take 15 in the numerator, 3 in the denominator, and you divide. And you think, how many 3's can go into 15? That is 5. So we're going to divide by 5 here. Do the same thing to the bottom, because what you do to the top, you do to the bottom. And then you think, how many 5's can go into 25? And then that answer is 5. So 3 over 5, 3/5 is equal to 15 over 25. Very good. Oh, that's not very good.